Hello, everyone. My name is Andrzej Stroiński, and I will have a pleasure to present you the talk about developing human-like bots for cooperative action RPG games. And this presentation will be based on our case study during the development of Gatewalkers game. I will tell a little bit more about the game itself and the development during today's presentation. But first of all, I would like to give some acknowledgement because this work was founded by Polish National Center for Research and Development grant, and all the information data you have here on this slide. Oh. Okay, so first let's start by introducing myself. I'm Andrzej Stroiński. I'm co-founder and CEO of Softworks, the indie game dev studio from Poznań, Poland. I am also the creative and game director of Gatewalkers game. And also I am an assistant professor at Poznań University of Technology. Here you can see some of my background from game development. It started since 2015. And also I have some background in the research field. I've started working on the research in 2011, and I do my PhD in process mining. So this is the part of the reason why we are able to maybe facilitate this information, this field of science into the developing our bots and our game. So let's start from finding out what is in fact a bot. A bot is a computer program that generates and operates as an agent for a user or other program, or to simulate a human activity. So from the perspective of this definition, of course there is a lot of and different definitions of what the bot can be. But the most important stuff is that it's able to simulate a human activity. And this activity can be simulated in different ways. For example, we wish to create a bot that is able to play the game and win the game. So be a good player, for example. We can also create a bot that will play like a human. So we want to bot to play like humans, so other players are not able to tell if they are facing, for example, player or bot or artificial program. And also sometimes we wish to simulate the human, the exact human, the one person. So for example, we wish to know that we are playing with this exact person and we are facing it in the game. So in case of Gatewalkers, because we will go through our problem during the creation of bot for Gatewalkers, but first let's take a look what Gatewalkers is. It's an isometric cooperative action RPG where you are moving your character using WSDA, so it's a little bit different than like in classical action RPGs, and where you have a truly skill-based combat. And what does it mean? It means that you need to aim with each spell, you are able to avoid each spell, etc. You have deep character customization based on the idea of you are what you are, so the players can change their skills that they can use during the combat quite often. So there are a huge set of skills that you can use. What is more, the game is a cooperative game. So you are able to cast spells with other players, and we call this mechanic a cooperative combo. So this gives additional complexity of how you're able to play the game. There is a unique progression system, and also during the game you do not only fight enemies, but also you are going to explore world, you're trying to survive on harsh environment, and of course you are doing some quests, do objectives, etc. So why even care about creating a bot? First of all, what we wish to maybe achieve is we wish to create an enemies with artificial intelligence, so they are more intelligent than just some rule-based system. Maybe we wish to increase a game population. If there is a game which allows to play in multiplayer and we do not have a lot of players, maybe sometimes it's good to have artificial players who can populate the game. Or we can create a bot that can act as a partner in, for example, cooperative missions. If we have mission that needs a player to have a partner, the bot can be the solution here. Or we can mimic some players, like we know how our friend is playing the game and we wish to play with that friend our game, so we can simply mimic the behavior of such player. So it's very important in order when you are creating a bot to know the game loop and see how the bot will perform in this game loop. So First of all, in the Gatewalkers, you are preparing for expedition, and expedition is one run of the game which takes around 30 to 40 minutes. And during such an expedition, what you need to do, you need to fight with enemies, you need to do the objectives, you need to gather some resources in order to progress your character, you are also exploring the world, and you try to survive. All these mechanics is very important because the game is cooperative game. So the bot is not just a, let's say, random creature or enemy that can go whenever it wants, but we need to take into account how players are playing the game. If, for example, this bot is going to be our partner, we need to know how to play with the partner. After finishing such an expedition, the player usually goes to the hub. So when you are in the hub, you are able to progress your character, prepare for next expedition, and so on. So the core elements of the gameplay loop where the bot needs to be interested in is the second point and the third point. So the expedition itself, and also taking into account the cooperative mechanics. Okay, so what's mean the skill-based combat? As I said before, you're aiming with each spell. So here you can see the indicator how you are casting the spell. So it's not only, let's say, timing and tap target like you're targeting one creature, etc. But you need to use the skill in appropriate place in the world in order to hit the enemy. Also, all the enemies are trying hit you at the same way, so you are able to avoid such spells. As I said, there is a number of skills that you are able to change or switch without changing the character. So, for example, it's possible to change the gear that you have, and because in the game we have approach you are what you were, when you are changing your weapon, you are changing your helmet, etc., you have a different set of skills. So, in fact, there are a number of possible builds, which makes it even harder to develop a bot, because there is a huge number of combinations of how we can build the character. And finally, in case of combat, you need to remember about these cooperative combos. So, in fact, multiple players, when they're playing the game and fighting together, they're able to combine the elements that they are using in order to create a new skill. So, when we are on the expedition, we are not only fighting, so the bot cannot only fight. The bot needs to also, if this bot wish to simulate the exact players or other players, sometimes it needs to also explore the world. So it needs to go to different places in the world and finding some new stuff. Also, this bot needs to gather sometimes resources. Why? Because sometimes you need the resources, for example, to start a fire, to create new gear, etc. And do the objectives or help when you are doing the objective. Because, for example, here, when this player is trying to start the objective, the enemies will attack the player. So the bot needs to protect the player, so just like they are playing in cooperation. And finally, the bot needs to survive in the harsh environment. In the Gatewalkers, for example, when you are on the ice world, you need to fight with penetrating cold. So the bot needs to know that it should wear warm clothes, etc., etc. So we see that the bot, in fact, is not cheating or using a different weapon that we need to use when we are playing the game. So what to do? So just to summarize how complex the problem is here, is that if we wish to create a realistic bot, we need to remember that we have over 200 items, each with different spells, etc., around 40 to 50 hours of gameplay, and we have different goals depending on where we are during the expedition. Maybe we are in combat, or we are gathering, exploring, etc., etc. And also we need to remember that the game is possible to be played with up to 4 players. So how to handle such complex situations, such complex environment, and make the bot to feel realistic, and being able to manage this as an indie studio, and how to teach the bot to to play realistic. Because if we have unlimited budget, it's of course we can do a lot of different methods and we can see what works best. So the classical approaches for creating bots is usually machine learning. For example, neural networks, we can use neural networks. We can use statistics. In a lot of games, just simple statistics can be really great, and it even feels very realistic if you are making a decision of the bot based on simple statistics. And overall, all the methods that we know as AI, yeah? But what we can find out when we are analyzing how players are playing the game is that players are usually playing with some patterns. And if we think about each gameplay session as a process and all stuff that players are doing as an activities during this process, we can make use of the methods from the field of research called process mining. So the process mining is a quite young field of research where we are discovering the knowledge about running processes based on event logs. So going to the game dev environment, we can discovering knowledge of how players are playing the game based on historical information about how the players have already played your game. So when you are, let's say, gathering data as event logs for debugging, etc., if you add not many extra information, you are able to gather appropriate event logs to be able to find out how players are playing your game. There are 3 types of process mining, but we will be focusing on process discovery. So we are gathering the event logs of how players have played the game in previous gameplay sessions, and based on that we will discover the patterns how players are playing the game. So the possible solution is here, so you can see the process model. It can be a completely different model, but here we can see the example model of how players have played the game. So for example, first the player uses skill A, B, C, then it's possible sometimes it uses skill D or E, and then finally F. So, in fact, what we can see, this is a very complex, because if we wish to create such a complex pattern, find a complex patterns of playing the game as complex as Gatewalkers for the artificial program, it is really hard. So what we can do, we can use the old rule of Roman Empire, divide and rule. So simply, let's divide this problem into a set of smaller ones. Let's solve the smaller problems and combine together the results. So if you take a look here, you can see the entire process. If we are storing, for example, from the Gatewalkers, from each run, the information about how player played the game, you will see the process, which is very complex. You can see it on the top left side. Each node is, let's say, the activity, like gathering resources, using skill, interacting with some interactive objects during the gameplay. So what we are doing simply, we are dividing this process into sub-processes where players were involved in specialized type of action. So for example, combat, gathering, exploring, doing objectives, etc. So why exactly we are doing this? So how we can pursue discovering such patterns how players are playing our game? So first of all, we need to gather gameplay event logs. So we need to define what type of event logs we need to gather, we will use, etc. Then we need to pre-process the data, and in this step we need to divide the problem into smaller problems connected to the types of the moment in the gameplay where we are in the game loop, like we are in fight with enemies or we are doing the objectives, etc. Then discover domain-specific behavior, so patterns during this type of, let's say, actions, and then connect each sub-problem into complex, let's say, solution. We call it hierarchical brain, and I will show you this in in a second. So first of all, this is a very simplistic event log based on Gatewalkers during the combat. So what we can see here, we can see the type of activity that player Raven is doing, on which creature, and what is the outcome of this action, yeah? Of course, there's a timestamp, etc., etc. But if we have a little bit more complex game, for example, we are not only fighting with enemies, but we are also, let's say, gathering resources, we can see here that these activities can interleave each other. So what we need to find out first is to find out the sequence or even sometimes sequence which is in parallel with other sequences of doing some complex actions like combat, like gathering iron ore or something like this. And we can divide it as a separate event logs. And based on that, we can discover the behavior in the form of example graph, this type of graph. How we are doing it? This is just one example. If we use, for example, the alpha algorithm of discovering patterns, here you can see the paper which shows how to do it exactly. But here you can see that if we see in our event log this type of traces, like, I don't know if you see my cursor, yes. So if you see, for example, the activity A is always before B and sometimes A before C, but never B is directly following C and vice versa, then we probably have the XOR split pattern. So this is one example of how we can do it. In fact, we as a studio have used a fuzzy gameplay miner, a different algorithm, a heuristic algorithm based on fuzzy set idea. If you're interested how this algorithm exactly works, you can go to the YouTube video from the right bottom corner. It's in my last year talk about discovering gameplay. It's a geek talk, so you're welcome to check it out. But the outcome of usage of this algorithm is a graph that we can see on the right. And as you can see, the nodes have different colors. So if the node is red, the significance of this action is very important in this pattern. And also the colors of nodes, which shows the correlation. So how important is transition from one activity to other activity during the gameplay. And each node can symbolize a skill. If we are thinking about combat, it's a different set of skills, and the order of the skills that player is using. Or if we are gathering resources, these activities are gathering iron ore of tier 3, chopping wood, etc., etc., or doing the objective, hacking the device, etc., etc. So when we apply this algorithm to this divided log, we have a multiple patterns, sometimes very simple, like just a sequence, because this part of game design is very simplistic. But for example, for the combat, it's usually quite complex, so it's not an easy to see right away the pattern. And so right now, we see the solution of these small problems. So when we know the bot is in combat, let's say, we know that if we execute appropriate skills in appropriate order that the graph is telling us, we can replay how the player played the combat. Same for exploring. So what parts of the map has been explored during the gameplay. Of course, we have a multiple data from different gameplays of the same or the group of players. So this is, let's say, most average results. But how to find out when the bot should change the way of action from fighting with enemies, so from the combat state to, let's say, gathering state. So what we are doing, we are going back to the entire log, not divided, and we are checking what was the situation around the player in different dimensions that lead to the transition from the state of combat to the gathering. So what we have, we are checking, for example, what was the average number of enemies that lead the player has left the combat and start gathering resources. So we can see that here we have almost half half enemy. Yeah. Also the timestamp. So how long the combat has been done before we move to the gathering. And based on that, we are creating the edges which are telling us if this situation happens, we probably need to change the pattern. So not playing the combat pattern, but gathering pattern of a player behavior. So the final result, this is an example, of course, very simplistic, it's a little bit more complex usually, but this is an example result of how such a result of applying the algorithm is look like. So when we need to change between different states. What is important here is that there's just example of 3 possible, let's say, variables that tell us how to change the state of our bot. But sometimes in different games can be more variables, and we need to be aware that if we have too many variables, this problem is becoming more and more complex and time-consuming. So, I told you how we are doing it, how we are, let's say, creating the brain of the bot based on fuzzy miner and then combining it together based on data in event logs, but how we can measure the outcome, if it's really good or bad. Is the algorithm in fact works or not? So we have here in fact, we have done the research and we have checked the 3 approaches. The top approaches is the approach using the process mining approach. The second one is using classical machine learning approach. And the third one is combining these approaches. In fact, the machine learning, there was a different algorithm, and we are just showing the average value of how it performs. And as you can see here, you can see that in case of, for example, Great Hammer and just a combat, it seems that the machine learning works better in case of, for example, metric like accuracy. But what is very important when you are trying to compare the one method of, let's say, bots and the second method is that each metric has different outcome and measure different stuff. This is just checking if our bot was very accurate by replaying the sequence of actions. But if we take a look, for example, graph measures, so the situation where we are checking if discovered pattern, in fact, in 2D dimension world is in fact able to replicate the entire structure of which activity was done before other activity, how they are correlating with each other, or how important is playing this activity after the past one, because maybe the first activity is giving debuff to the enemy and the second makes a ton of damage, etc. Then we need to use, for example, the graph measures, like Jacquard score or graph at a distance. And in this situation, you can see that the process mining for hammer and bow is bigger than using classical average machine learning methods. So as you can see, you always need to check what metric you should use in order to compare the methods. So just to go to the summary of this really short, let's say, introduction to creating the bots in action RPGs, is that we have shown that bots can be made for even complex games, and the solution for this approach is to divide the problem into smaller one, the set of small domain-specific problems. We are able to create a realistic bot using historical data, and what is important, we have here a true gameplay. So you do not need to create and learn the bot by tons of gameplays from testers in order to teach the bot how to play, because we are using just the gameplay, the data that we can gather just by players playing the game or playing demo or playing the beta version of the game, etc. In fact, the situation, what we need to have in mind is that if we are using the process mining methods, we always have data that in fact happened in the past. So there is no possibility to store the information that never happened. So in our game, it is possible to play in some way, But if no one have ever played this way, we will never know. This is sometimes a good thing and sometimes a bad thing. What is more, the bots can play and mimic exact player. So if we will teach our bot to using just event logs from one player, then we can create a behavioral pattern of how player plays the game, this exact player. But if we want to have a pattern that represents the group of players, like casual players, hardcore players, I don't know, then we need to just gather the group of players into the one set of event logs that we can mine and discover together. So yeah, that's all that I have prepared today, and thank you very much. If you wish to contact me, here you know how. Also, the Gatewalkers is right now in a PGA, so you are welcome to check the game by yourself. It's a demo. The game will be released later this year. So if you are interested, you are welcome to try it out. And if you have any questions, do not hesitate to ask. Thank you very much.
So first of all, thank you for your speech. I never heard of process mining before, so today I learned something new. My question is, I see a lot of similarities between what you showed us and with classical machine learning. So you already need to have some data. I see, just as you showed us, the data is already vectorized. So why exactly you have chosen this method? Were there some obvious advantages of using this over the machine learning techniques?
In fact, this approach is a little bit different because it's more like just data mining, not machine learning where you are teaching the bot itself how to operate. And the differences is in that situation, if player or the game design is enforce player to play with the patterns, this method is more accurate and it can teach and learn faster. Of course, there are some games which have a lot of possibilities and not always the process mining will be very accurate, but it usually will be faster. What is more, we do not need to, of course, based on the different method of machine learning that we are using in order to teach bot how to play, we do not need to use, let's say, new data or divide the data into training set, etc. But we are just taking the historical data that we already have, yeah, and we are creating finding the pattern, and that's all.
Okay,
yeah?
Thank you. That answers my question.
Thank you.
Hello.
Hello.
So, from what you've said, this process doesn't seem very resilient to situations that players have never encountered before. So, do you have situations like this in Gatewalker? Like, for instance, there are procedurally generated, and more in general, how would you handle, a live game that is updated and where skills change, etc.?
Yeah. So, using the process mining in a situation where we add a new region or a new set of skills is in fact problematic, yeah. So in order to teach the bot how to play on a new region with new skill set, it simply will make us to, let's say, create a test server where player can play and test the feature, and based on this data we can learn the bot how to play. Yeah, we always need to have a data, and it cannot be just one gameplay too. We need at least a number of gameplays that we can use in order to find this most important behavioral pattern in the gameplay, yeah?
Makes sense, thank you.
Thank you.
Thank you for the presentation. It was very interesting. I would like to ask you, because you said that you have a choice to create a bot based on one player, on perhaps a group of players.
Yep.
And so I wanted to ask you if in the game, for example, I'm playing the game and I want to choose, do I have an option to choose? Like, for example, I want to play with bot that plays like my friend, or give me a casual bot, or give me the best bot you get.
Okay.
So how does the player, what do you tell the player? And what is the player choice in the matter of what bot will accompany them?
Okay, the question is about the game itself, the Gatewalkers, yeah?
Yes.
Not the internet. So,
Yes.
So in fact, this method is right now under the development. So the choosing bot won't be the case for even for the release. The bots is something that we will add later, yeah? It's not something that we plan to release during the release date of Gatewalkers. So in fact, it's hard to tell you how it will work, because the first problem that we have here is, let's say, some part of legal issue, like first player needs to allow you to gather the data from the gameplay in order to create bot that will mimic this his behavior, yeah? So in this manner, it is something like a future part of what we need to do later on.
Okay, thank you.
Thank you.
Time.
Okay, so
It's over.
maybe we will talk after the talk, because I don't want to take a time from next speaker. So if you could please just wait a little bit, I will come to you. Thank you very much.